Let me get this set up for you here. All right, so we're going to talk about what are called arithmetic sequences in series. First, basically today we're going to talk about an arithmetic sequence. It's a special type of sequence. Like I said, the one we just kind of had up there, it had a common difference. You add the same number to go from term to term. That's called an arithmetic sequence. It's a linear function. Okay. Tomorrow we'll talk about finding sums of series. Right? There's a special way we can do that for an arithmetic sequence. There's shortcuts. All right, recall that linear functions have a constant first difference, just like some of the sequences we've looked at so far. Notice also that when you graph ordered pairs and a base event of arithmetic sequence, the points line a straight line. So an arithmetic sequence it can be modeled with a line or a linear function. Okay. So thus you can think of an arithmetic sequence as a linear function with sequential natural numbers as domain. So our domain is going to be 1, 2, 3, 4, 5. It's not, we're not going to go 1.2 or 1.6. We have to use the counting numbers, the natural numbers. Okay. So it's a linear function with the exception that we can't put in any fractional values. We have to use our natural numbers or counting numbers as our domain. So first of all, it says determine whether this sequence could be arithmetic. So an arithmetic sequence is like we talked about. It has a common difference. All right, it's something that has a common difference. Now, if we wanted to identify whether this was a arithmetic sequence or not, we would say, all right, let's find our differences. Well, this goes up 6, this goes up 6, this goes up 6, and this goes up 6. So in fact, that is a arithmetic sequence, isn't it? The pattern is we always add 6. Now, what would the next term be? It would be 20, wouldn't it? Okay. This is cooperating here. All right, there's our differences like we found them to be 6. And the sequence could be arithmetic with a common difference of 6. And the next term we figured was 20, 14 plus 6. Okay, 14 plus 6 is 20. Okay. So an arithmetic sequence is a special type of sequence. Right? We'll talk about another one in section 4, but arithmetic sequences is one of the 2 special types of sequences. All right, what about this one? Is this an arithmetic sequence? Well, the way to do that would be to find differences, wouldn't it? All right, the first differences are what? This would be what? Down 3, down 6, down 9, down 12. So since those aren't all the same, that's not going to be a arithmetic sequence. Now, what if we went further? What if I found my next level of differences? Down 3, down 3, down 3. What type of a function would model this sequence? If second differences were the same, what type of sequence would it, or what kind of function would it be? It'd be quadratic. So if we were trying to figure out a rule for this sequence, it's not arithmetic, but if we were trying to figure out a rule for that sequence, we would pick quadratic regression to figure that out. Now, even though it's not arithmetic, could we find the next term, guys? Do you think we could find the next term? What would the next term be?
Negative 45.
How about negative 47?
Yeah.
Okay, and you're on the right track. We subtract 15, right? You're on the right track. Negative 47, because if we continue this pattern in green, the difference would be negative 15. That gives us to negative 47. Okay, so I think that's what you're on the right track there. Okay, so just because it's not arithmetic doesn't mean we can't find the next term, but makes it more difficult. Okay, so it's not arithmetic. Now, if we identify something as an arithmetic sequence, all right, remember something that is arithmetic has a common difference. I'll abbreviate there. And that also is going to tell us that it's a linear function. It's linear. Okay. So what we can do is if we identify something as an arithmetic sequence, there's a linear function we can match it to without having to use Desmos. Okay, realistically. Doesn't mean you can't use Desmos, it's just that we don't necessarily have to. All right. Here's what this looks like. A sub n is a sub 1 plus n minus 1 times d. All right. Now, we got to know what all those things represent here, and that's what we're going to talk about right now. Now, d is our common difference. All right. That's like our slope, isn't it, of our line? Wouldn't that be our slope? For one term number, that would be like our slope of our line if we're equating this to being a linear function. Okay, that would be like our slope. Now, what this kind of equates to, this form for the general rule for an arithmetic sequence, it kind of takes us back to something like this, and it's really, I'm going to write it a different way. Okay. Now, it's that what's in green there is maybe written a different way than what you're familiar with, but really, I think we've talked about it earlier. There, not a lot. We haven't talked about it a lot, but I think, didn't we call that point slope form of a line? Does that look familiar? Okay. So realistically, this rule we're coming up with right here, that's in red, a sub n equals a sub 1 plus n minus 1 times d. That's just point slope form fitted to a sequence. Okay. Notice the common difference is like the slope. And realistically, this is saying our first term number is 1, and this is our first term. Okay, so it's like the point we know is our first term. Our first term is a sub 1, and our common difference is our slope. Right, so trying to make, it looks abstract with the subscripts, but it's really nothing more than point slope form. And that's something you should be kind of familiar with. Now, we're going to use it in a couple circumstances here, but this is very important. One of the more important things we're going to cover today. Okay. So the two things we need to know if we're going to write a rule for a arithmetic sequence is the first term and the difference. Okay. And I'll go back on that. Maybe we don't need all that. There's other things we can use too. All right, but we'll get to that eventually. All right, so that's once again very important. And I think it's on your note sheet that I handed out back in whenever we started this chapter. All right. All right, so find the 11th term of the arithmetic sequence. Now, we could do that without coming up with any rule whatsoever, but we're going to spend some time talking about developing a rule here. First of all, they told us it was an arithmetic sequence. Can we identify that it is? Okay, what's our common difference? We're going down 2, aren't we? So could I keep subtracting 2 until I found my 11th term? I could, right? Negative 11, negative 13, negative 15, negative 17. We could do that, right? But a quicker way would be to come up with that rule. Any term is the first term plus n minus 1 times d. Well, the two things we need to know is we need to know the first term and the common difference. We know those, right? So for this specific sequence, any term would be negative 3 plus n minus 1 times negative 2. Now, I'm going to erase some of this. I'm going to write it a different way. I don't like the way that looks. It's not wrong what was written there. I just don't like the way it looks. I would prefer to write it like this. Is that okay? Am I just changing the order of multiplication? It's not a big deal, right? Not a big deal. It just looks cleaner to me. So this would be a way you could find any term of that sequence. All right, that's basically the equation for the line that would join the points 1, negative 3, 2, negative 5, 3, negative 9, 4, negative 11. Excuse me, 4, negative 9. I skipped one. 3, negative 7, 4, negative 9. Sorry. Now, how are we going to find the 11th term? Pretty easy. What do? Plug in 11 for n. Negative 3 plus negative 2 times 11 minus 1. Well, that's going to be negative 3 plus negative 2 times 10. That would be our 11th term. Now, we could have found negative 23 by just continually subtracting 2. But I think in the long run, this is going to be the best way to do it. You're going to want to be, because what if it was the 37th term? Would you want to subtract? No, you wouldn't want to do that. Okay. All right, so we want to make sure we're getting familiar with using these relationships. All right, so once again, the two things we need are the first term and the common difference. Okay, point slope form. First term is our point, common difference is our slope. Okay, what else could you use to figure out the equation for a line? 2 points? Okay, so we could do that also. Maybe we'll run into that later. All right, let's see what, they're going to show you the same work I just did. Common difference is -2. There was our general rule. We plugged in the values we knew, we got -23. Okay, we got -23. All right. And you know what? Realistically, if you don't like the way this is written, could we write this way? Would it be the same thing? Would that be the same thing? Yeah. Okay. That looks more like a line to me, but both of them are fine. Okay. They're this exact same relationship. The one at the bottom there maybe looks cleaner. You use whichever one you want to. Okay. I'm just looking at our little build sheet here. Yeah, it's on the back here, the general formula. Okay. All right. Questions on that? All right. Let's try another one here. Find the 11th term here. First of all, it says it's arithmetic. Let's make sure it's arithmetic. How can we make sure it's arithmetic? Find the differences. Down 0.05, down 0.05, down 0.05. I think so, right? What would be our next term? It'd just be 9, wouldn't it? Yeah. So this is definitely an arithmetic sequence, right? It has a common difference of -0.05 or -0.05. Okay. So the easiest way, in my opinion, to find the 11th term would be to say, all right, any term is the first term plus the common difference times n-1. Once again, I turned it around just because I think it looks cleaner. If you write it the other way, it looks like you're subtracting 0.05, right? So I think it looks better this way, but once again, I'm not trying to confuse you. All right, so this would help us find any term of that sequence. All right, this should help us find any term of that sequence. So if we want to find the 11th term, it would look like that, wouldn't it? So that would be 9.2, and this is 10, right? Minus 0.5. Is that going to be 8.7? And you can use a calculator if you want to. That's fine. I'm not using a calculator up here because I'm not going to go back and forth to Desmos and all that other stuff. But you can definitely use a calculator if you need to. Okay. And a lot of you are going to want to do that. That's fine. All right. So the 11th term appears to be 8.7. All right. The 11th term appears to be 8.7. Okay. Questions on that? All right, I'm gonna have you try one. Same type of question. I'm just gonna put a different sequence up here. All right, with that sequence right there, I want you to do two things. Find the general rule and find the 11th term. Find the rule that describes that sequence and find the 11th term. The most efficient way to find the 11th term is to find that rule. I know we can keep adding the difference as many times as we need to, but what if it was the 110th term? You wouldn't want to do that. And I'm evil enough to do that, aren't I, Jackson? Got it? You don't? Okay. It's fine, no, it's fine. Just practice. First time you're doing some of this. Anybody need more time? Or are we good? Or as far as we're gonna get? All right. This is what I got. All right. So see, there you go. You're not sure because you've never done it before. I get it. Yeah, I understand. 74. How many people got 74? We're gonna go through how to do it now. Okay.
What did you mean find the rule? Is the rule?
The rule will help us find 74 quickly.
The rules that equation.
Yeah.
Okay.
Here's the rule. Any term is the first term plus the common difference times n minus 1. That's what I would call the rule.
Okay.
Okay. All right. So maybe they don't use the same terminology. That's what I would call, technically that's called an explicit rule for that sequence. Because if I know the term number, I can plug it in and boom, I have it. Okay. Hopefully you recognize right away the common difference was 7. Right? If you're not sure, you find your differences. 11 minus 4, 18 minus 11, 25 minus 18. They're all 7. Well then, if we plug in 11 for n, the 11th term is 4 plus 7 times 11 minus 1. That's where we get that 7. Okay, that's where we get that 7. And if I asked you to find the 15th term, that would take you there, wouldn't it? Or the 23rd term, right? You could use that rule to jump and find any of those terms real easily. Okay, that's the benefit of having that rule. All right, that's a benefit of having that. All right. Question. How many people had that? A lot of people had it? Okay. Once again, if you absolutely forgot how to, how to use that formula, could you find the 11th term by adding 7 enough times? You definitely could. It's not really what I'd like to see, but it's better than getting it wrong, right? It's better than getting it wrong. All right, so let's scoot ahead here. That's what we ended up with before I modified the question. Okay. Now, we can also use that explicit rule or that rule we talked about in different ways, right? This says find the missing terms of an arithmetic sequence. Right? Find the missing terms of the arithmetic sequence. Now, so we have 17, blank, 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 and -7. Right? How could we fill in those blanks and figure out what those missing terms are? Anybody have any ideas? There's more than one way to do this. We're going to look at a strategy eventually that works all the time. What could you do? Okay, so basically, I think you're saying this is our first term. This is our second term. This is our third term. This is our fourth term. This is our fifth term. Is that kind of what you're saying? Well, we have 3 missing terms, right? There's 3 boxes, so you knew there was 3 missing. Okay. That's one way to do it. Okay, I could start, sir. Now, if we do this, and maybe this is not exactly what you intended, but if I know those two, think about what this type of arithmetic sequence is. We said it's a line, right? Do I know 2 points on the line? I do, don't I? All right. So here's how I would do this. Now, you might do it a little bit differently, but here's how I would do this. I would maybe say -7 should be 17 plus the difference, which I don't know what it is right now, right? 5 minus 1. Isn't this the fifth term? All right, look at that. If I know the difference, I can find those 3 terms real easily, can I? But what I'm basically saying is I'm saying I know 2 points on this line. I know that the fifth term is -7, and I also know the first term is 17. What's the only variable left? The difference. All right, so let's do some algebra to find the difference. I'm going to move this over here. That's going to be -24 equals, I can do the math in there, that's 4D. Is that right? What's the difference? Difference is going to be -6. Does it make sense that it's negative? Because we're going down, right? So we have 17. The next one would be 11. Then we'd have what? 5. Then we'd have -1. And look at that. It worked out real nice. We got -7. Right? So the point I want to make is we can use that general rule, and this is what I would call the general rule. Multiple ways, right? Previously, we used it to find the 11th term on the last sequence, right? Here, we use it to find the difference. So we can use it in more than one way. All right, we can definitely use it in more than one way. All right, that's how I would do that problem. Now, can anyone think of another way to do that without maybe using some kind of formula? There is a way to do it without using a formula like I did. Or do you like the formula? Well, I'm going to show you. What if, let's pretend for a minute, what if there was just one term in between? How would you find that? Okay, so how would we find the middle? Add them up and divide by 2. Okay, that would be what? 17 plus -7 divided is 10. 10 divided by is 5. Isn't that what it was earlier? All right. Now, let's look at these 3. What am I doing here? I got the eraser on. That's what it is. Can I find the middle again? What's the middle between 17 and 5? All right. What's the middle between, I'm still on the eraser, by the way. What's the middle between 5 and -7? All right, that would work, wouldn't it? Okay, so we can still use some math, and that -1 doesn't show up very dark. Sorry about that. All right, I like using the formula because the more familiar you are with the formula, that's going to be. When would this method, the second method, when would that get to be a lot? If there's a lot more spaces? Yes. Okay, if there's a lot more gaps, it would get a little trickier to use that other method.
So
But finding the middle worked. Yes.
what if there's 4 spaces? You just,
That's where it wouldn't maybe work as easily, right? Yeah, that's what we're getting at. That's the downfall of it. All right, and here's exactly what we did, right? Isn't that exactly what we did the first time? Yeah, if there were 4 gaps, I don't know that method would work. And that's exactly right. Because you'd have 2 middle numbers, right? Not just 1. All right, so that's why this using the rule is going to be way better. And we got the difference to be -6, and we found the missing terms. And we didn't do it this way. We didn't use the rule. We just kind of found them. We kind of figured them out. We used the recursive thought process. We subtracted 6. Okay. Questions on that? All right, here's another one. Why don't you take a few minutes to see if you can find the missing terms there? Give me another minute here. See, hopefully we're on the right track here. Once again, this is no different than if you know 2 points on a line, you can find the equation of the line. Right, just equate it to that. The only difference between a line and a sequence is a sequence, the only numbers you can plug in for n are natural numbers, the counting numbers. You can't put in 1.5, it would be meaningless. Okay. All right. I think this should be 1.5. I think this should be 1. And should this be 0.5? Is that right? So realistically, the key to doing this is you have to unlocking this issue here is you got to find the difference. Now, keep in mind, this is our first term. And this is our fifth term. So that's what I'm going to use. I'm going to say our fifth term is our first term plus difference times 5 minus 1. And I don't know the difference. So I'm going to find it. -2 is going to equal 4d. So d is -0.5. And that's how I came up with 1.5, 1, and 0.5. Right. Any questions on that? Now, want to make sure you're familiar with using that rule, because tomorrow we're going to kind of take that things a little further and talk about, we're going to have to use that rule tomorrow in what we talk about. What we're going to talk about tomorrow is an arithmetic series. Okay, an arithmetic series, which we talked about a series last week. A series is the sum of the terms of a sequence. So we're going to be finding the sum of the terms of an arithmetic sequence. That's going to be called an arithmetic series. All right, we'll do that tomorrow. Okay, so kind of a 2-day lesson here. All right, so here are some questions to work on from section 3 for tomorrow. 21 through 29 and number 50. Okay, one of these, not working with these formulas before we take a test or quiz isn't going to be a good plan for anyone, just so you know. All right, you want to make sure you're practicing these as we go, because